everyone, welcome to another PSC session. Today we are going to discuss a problem named arrival and departure. Okay, let's move to the description part first. It's saying you are given an undirected graph G with n vertices and e edges and a start node S. Okay, you have to find the arrival and departure time of each node if a single pointer is used to traverse all the nodes starting from the node S. Okay, and now it is saying refer the sample input for better understanding. We'll look into it later. And another thing it is saying is it takes 1 unit of time to move from one node to another. Okay, so let's first clarify that arrival and departure are the two kinds of action that are going to happen while traversing. Okay, arrival means when you are reaching a node, and departure means when you are leaving a node. So if any of these two kind of actions happens, then it takes a 1 unit of time. Okay, that's what we need to consider mainly. And there's a node given, it's saying the nodes must be processed in the order in which they arrive in the input. Okay, so let's write the givens first. What are those? Graph, we have a graph G with n vertices and e edges. These are given to us, and the number of vertices, E is the number of edges. As is the start node for the traversal. And while traversing, it takes 1 unit of time to move from one node to another. And what you need to do is we need to find the arrival and departure time for each node. Okay, and the node was process the nodes in the order in which they were arrived in the input. We'll show later. Okay, about this. So now let's try to understand the sample input and output. Okay, so what is my sample input given? The first line of the input contains n, the number of vertices, and e, the number of edges. Okay, so let's write it first. N equals to 5, number of edges, e number of nodes, and e equals to 4, number of edges. Okay, now next e lines contains two integers x and y, denoting an edge between x and y. So x and y is nothing but the pair of nodes, means these two nodes have an edge between them. Okay, so e lines, it is saying, okay, so number of edges, it is equal to number of edges. So let's add these also, x and y. 1 2 2 3 3 4 and 4 3 and 4 3 are the edges given in our sample input. 1 2 2 3 3 4 and 4 3. Okay, now it is saying the last line contains S, the starting node from which the pointer starts traversing. Okay, so our starting node is 1. Let's write it also 1. Okay, now let's understand the whole scenario by looking at the graph. Okay, so according to the given informations of nodes and edges, the graph will look like this: 1 2 3 4 and 5. 1 is connected to 2, 2 is connected to 3, 3 is 4, and 4 is connected to 3. As it is an undirected graph, so if 3 is connected to 4, then 4 is connected to 3 already. Okay, automatically. And we can clearly see that node number 5 is alone. It have no edges with any other nodes. Okay, so that's how it is like. We have marked the starting node, and now let's put the graph in the adjacency list. I mean, that's how we process a graph, right? Usually. So let's make the list. So with the edges information 1 to 2, we have put 2 uh, in the list of node 1. Okay, but as I told you, it is an undirected graph. So if 1 to 2 is given, then 2 to 1 must also be there. Okay, means if one have an edge, node number 1 have an edge with node number 2, then in an undirected graph, node number 2 also have an edge with node number 1. Okay, so that's why when we write a single edge, we do two actions. In the list of 1 and in the list of 2, we include both of these. Okay, similarly for all other edges information also, 2 3 I mentioned here, 3 4 and 4 3. Okay, now, because the 5 doesn't have any edge with any other nodes, so that's why its list is going to be empty. Now, to understand it more clearly, let's keep some records. Okay, records like which node I have already visited, what is the arrival time for a particular node, and what is the departure time for a particular node. I have put initially 0 because 0 means nothing, means when we have not traversed any of the nodes, means the nodes have not been visited, that's why 0. Okay, these are the node numbers 1 2 3 4 and 5. So let's start the traversal from the start node, okay, which is 1. Because we are starting from node number 1, means we have not moved from another node to node number 1. That's why the arrival time for 1 will be 0 because there is no movement. Okay, I think we'll agree with that. That's why arrival is 0 for 1. Now we are moving from 1 to 2. Okay, so 1 movement, it will be incremented, arrival will be 1 because the 2 is connected to 1. Now 3 is connected to 2. Okay, so the arrival will become 2, 1 greater than previous. Okay, now we are moving from 3 to 4, so arrival became 3 for node number 4. Okay, we are putting everything here in our records. Okay, now as you can see, this node number 4 doesn't have any other node to move on because it is not connected to any other node now. So what will happen? We'll move back, means depart. So on departure, one action, departure is an action, means leaving the node is an action, so it takes 1 unit of time, so it will become 4. That's why in the departure of unit number of node number 4, the item value will become 4. Okay, similarly from 4 I'm moving backward, it will become 3. If I'm leaving 3, again the time will be incremented. If I'm leaving 2, again time will be incremented. If I'm leaving 1, okay, then again time will be incremented 7. But in this whole process we saw that 5 was never reached, never traversed, so its visited information is still 0. So that's why its arrival and departure time both will become 0 only, right? 0 and 0. I think we are pretty clear about this whole situation, how things are happening and how we reach to this particular state. Now we have all the records of visited, arrival and departure. So what are our observations here? We are observing because we need to implement it also. Okay, so we are showing you observations so that we can connect it with some concept that what real algorithm that we are going to use here. Okay, so let's set it first. Once we start from a node, we reach all the nodes, yes, that are connected directly or indirectly to the start node, right? Yeah, we started from 1, we move to all the connections of 1, then we move to all the connections of those connected to 1. Okay, and so on till the end, till our connection is stopped, right? There is no more nodes connected. So that's why connected directly or indirectly to the start node. Okay, 4 is indirectly connected to start node, right? And then next is, if you have observed or recalled, this is exactly what happens in depth first search, or you can call it depth first traversal, DFT also, right? They are similar according to what you are going to find, right? It's like when we start from a node, we move to the depth. Okay, we move and move and move to all the nodes that are connected at once, and then we start coming back, right? That way we traverse all the connected nodes from the node that we started at, right? So that's what DFS does. That's why we are going to say the algorithm being used here is the DFS. So on reaching a node, the actions are happening, right? There is more to this, not just a DFS. DFS is like just a traversing, but we are doing something also. We are calculating or recording the time also. So according to the actions, so on reaching a node means arriving at the node, record its arrival time A, and on leaving a node means departing from a node, record its departure time D. Okay. One more thing is, at the last, for all the unvisited nodes, the arrival and departure time both will become 0 only. Okay. So these are all the observations. Now let's put all these observations in the implementation. But first, see let's compare the output also. So according to these observations, what are our output here? This is my node number, this is my arrival time, and this is my departure time. Okay, so my node number. So 107, 216, 325, 434, and 500. Let's compare it. See a sample output. What is the output? 107, 216, 325, 434, and 500. It's exactly the same. Okay. So now let's move to the pseudocode part. Step number 1. We need to create an adjacency list. Let's call it G. Okay. For all the given nodes and edges, for all the information that we are given with. Okay. Step 2. Create arrays named visited, arrival, and departure. And what is the size of those arrays? N means equal to number of nodes. Okay. Step number 3, initialize all the items in the visited, because we know that if we have not visited any item in the node, I mean any nodes in the graph, then its a visited status should be 0. And initially the time, because we are keeping a record of time also, no? So it will be 0. Now step number 4, we are going to run the DFS algorithm here. From where, or from, on what? This is my graph, and S is my start node, okay? So what are we doing? For the very start node in the visited, we are marking it as a visited one, okay? Then we are recording its arrival time. Initially t was 0. We can see that here t was 0. So initially it will be 0. We are incrementing our time counter. And now what we are doing? We are now traversing the adjacency list of that node, okay? List means that node, that start node is connected to the other nodes, okay, to whatever nodes it is connected to. We are now going to traverse those also from the list. And the list, what we are checking, if those nodes are not visited, means if they visited status 0, then again we are running DFS on those nodes, okay. That way we will reach all the nodes that are connected with each other, okay, from the start node. And once we are over, now the all the connected nodes are over, means we are at the last node. What will happen? We are recording the departure time. It is here. Okay, departure time is recorded for that particular node, and we're incrementing the time. Okay, that's what is happening here. Okay, so after this, the whole 4-step completion, we will have our visited array looking like this, arrival like this, and departure like this. Okay, similar what we saw earlier. Okay, and we can still see that the, because I was not connected to the starting node in either directly or indirectly, so it will not be visited. It's a visited status will be 0 only, and that's why its arrival will be 0 and its departure time will also be 0. Okay, now step number 5, it's about printing. Okay, printing the output. So we are going to traverse all these 3 arrays at the same time, but comparing the visited status first, because if an item or node is not visited, means if I is a node number, then visited of I, status of I of that node is 0. It's not visited, it means then what will you print? I means node number. Let's say here 5 was not visited, right? That's why it's a visited status is 0. So 5 space 0 and 0. And in the else condition, it is when it is visited. Okay, when it's a visited status is not 0 but 1. Okay, so what will print? I means node number, that is for node number 1 it is visited. What is its arrival time? 0 and departure 7. Okay, so 500 for not visited and visited 107. Okay, you can see it clearly. So the output will become like this, and we have already compared it. It's the same output as it is given the sample output. Okay, so I think we understood it. The whole scenario, the whole process pretty much. I didn't explain DFS because we did all the explanation with the assumption that you already know DFS. So I'm not going into depth of that, and that's why I'm not driving the DFS part. But I've showed you because we assume that you already know. So that dry run part will be up to you, and I hope you understood it very well till here. So now let's move to the time complexity part. So what is a major thing that is affecting the time complexity? It is DFS. And what is the time complexity for DFS? Order of number of nodes plus number of edges. Okay, that's what the time complexity is for DFS because we're using it here. And what is the space complexity here? We are using the visited array of size n, arrival time array for size n, departure time array of size n. So ultimately order of if we add up, it will be 3, and you can just call it order of n, right? Let's not put it big O here and put a big O, sorry. Right? Yeah, so that's all for this session. I hope you understood it very well. Thank you. And we'll meet in another session. Till then.